All right.
God, we had such good questions so far.
Yeah. Dang it. So the issue is since a chemical reaction requires specific numbers of things, but we can't count those things, we have to take their mass, and then from that you can figure out how many of them there are. So if I want to make water and I've got one of these and one of these, and I'm going to make one of these, what I actually need is two of those, and I'll make two of those. So if I wanted to, I don't know, make a mole of this over here, I can't count out 2 moles of hydrogen. It would take me like billion years. And the same thing with the oxygen. But are you okay with saying that you could count how many objects there are by weighing all of the objects and knowing what the weight of one object is?
Yes.
So that's
You
how
don't have to be quiet. Sorry.
that's how companies who do shipping, like if there's like a shipping container and it's filled with iPhone, I don't know what iPhone they're on. Let's say iPhone 27. So I got a shipping container filled with iPhone 27s. How do I know that all the iPhones made it and that somebody on the ship didn't steal 20 iPhones on the way over? Well, they mass out the entire container. They know how much the container weighs. They know how much each iPhone weighs. And if it's a little light, then they know somebody broke in and stole some phones out of there. Does that make sense?
Yeah.
Um, my brother and sister had lived on the coast, and they had a zillion of those tickets because they saved them for years. The tickets that you get from the arcade at Seaside.
Oh yeah.
So like Skeet Ball and all those other games, and they give you like 5 tickets, and at the end of the day, you can get an eraser.
Yeah. They could
So,
probably get a frisbee with all those.
well, they actually got some good stuff because it was
Did they have a mole in them?
like 10 years. Yeah. So do you think that poor kid when they showed up, they had like 15 full-size yard trash bags, like the 33-gallon trash bags.
Oh
So do you think that poor kid counted all those tickets?
no.
No, he put handfuls of them on their scale, and then since they knew what each one weighed, then they could figure out how many were on the scale right then, and he could be like, all right, there's 400 here, and he could dump those and put some more in. I mean, it still took him a really long time, but at least he didn't have to count each and every ticket.
Gosh, I didn't know they weighed those. That's crazy.
Yeah, because some people do crazy stuff like my brother and sister. Okay. What else we got? Nothing?
Okay, I don't want to ask the other question too, but okay. Avocado's number
Yep,
or
that's them all.
that's a mole. Okay, okay. Just making sure.
That's the same thing. Yeah. They just named
Also
it
a sweet ass name.
right. He didn't come up with the number, but the work that he did 100 plus years before was incredibly important, and the people wouldn't have been able to figure out what the number was without understanding, without him doing his work and them understanding what his work was. It always reminds me of Jurassic Park, the book and or the movie, when he talks about you didn't take the time to understand if you should actually do this science because you were standing on the shoulders of giants. If you're not familiar with the movie or book, that makes no sense. All right, what else we got? Not that nobody has any questions about from chapter 4. Everything in chapter 4 is just easy. We're good to go with that. All the stuff on combustion.
I haven't got to chapter 4 yet.
Oh, okay. Well, then that's good reason.
Yeah.
I was asking questions from chapter 3. Sorry.
That's okay. We went over chapter 3 last week, so I didn't want to talk about 3 again. But maybe we should wait until Thursday to talk about chapter 4 stuff.
Yeah, I'm still working on that too.
I can't remember when the exam is finished. Is that this week?
Yeah, I think it's the 24th that it closes.
Yeah, Wednesday it closes. I think only 16 people have taken it so far, and there's 34 or 33 people in the class, so hopefully everybody gets on that soon.
Yep. So I'm planning to do it tonight since I finished chapter 2.
Okay, that's good. Yes, somebody, the first person that took it only reviewed chapter 1 and then took it. That they did really well on the chapter 1 questions and didn't do so well on the chapter 2 questions. So I would definitely do the SQ3R for both chapters before you attempted the exam.
Okay.
You have about a minute to answer each question is the way it works out. You can see that when you look at it before you take it.
All right.
As we go on with the exams, so what the material that was covered in the first one, say exam 2, is that going to have some of the same material? So is it cumulative, or is that just the last one? So, or is each one just based on a certain chapters?
Each one is specific to the chapters, so 1 and 2, 3 and 4, 5 and 6, and 7 and 8. But it is cumulative because, like, if you were taking an algebra exam, could you do the algebra exam if you didn't remember how to do multiplication and division?
Yeah, no.
Yeah, so that's pretty much how it works. It's not like I'm going to ask you specific questions from prior chapters, but to answer the later chapter questions, you have to know the material from the earlier chapters. Does that make sense?
Yeah.
Okay. So what I'm saying is focus on the chapters for that specific exam, but don't forget prior exam stuff because it'll bite you. In the face-to-face class, I tend to say it's all cumulative a lot, and actually some students bought me or made me like a glass frame with that phrase in it, and it's hanging in one of my labs. Okay, so what do we want to talk about out of chapter? Any chapter? Chapter 3. We talked about albedo, and we talked about carbon dioxide, and everybody's okay with what it like a question that climate skeptics have is, how do you know what the temperature was a long time ago, or how do you know how much carbon dioxide was in the atmosphere a long time ago? Are you guys okay with being able to answer that question?
Not really.
So on chapter 112 of 3, there's a picture of what looks like a long cylinder of ice. And so what we've done is created a drill that can drill down into deep glaciers and pull out ice cores. And so we can figure out how old those ice cores are. And then inside the ice cores, there are little pockets of trapped gas. And so we suck the gas out of there, and then that's the gas that was trapped when that glacier was made. So then we have a sample of the air from 10,000 years ago. And then we can check to see what nitrogen, oxygen, carbon dioxide concentrations were. Does that make sense?
Yes. That's pretty cool. That's pretty neat.
It is pretty cool. When you look at that on 112, you can see the ice core, and then next to it they show a microscopic picture of the bubbles inside of the ice crystals. So they basically just use an incredibly small needle to pull the gas out and then detect what gases are there. And we've gotten very good at it.
All right.
And you can see on the next chapter where it shows what the concentrations of carbon dioxide have been for the last basically like 400,000 years. And only one time did they ever touch 300 parts per million. The rest of the time they were usually somewhere between like 180 parts per million to like 275 parts per million, somewhere in there, with an average somewhere around 230 parts per million. And we crossed the 400 parts per million mark a couple of years ago.
Oh, wow.
So that might not sound like a big deal. When we're talking about almost doubling the amount of carbon dioxide that's been averaged in the atmosphere for the last 400,000 years. That's a dramatic change.
Dang.
And then the questions about, somebody gave a really good answer that I had never considered using this one particular word before. But when the sunlight hits the earth, and then that energy that was absorbed is reflected or re-radiated as infrared radiation. The question was about why nitrogen and oxygen gases are not greenhouse gases, and the person said that those gases are transparent to infrared radiation, and that's a really good way to think about it. So you've got a bunch of transparent gases in the atmosphere, but some of them are not transparent, and those would be greenhouse gases. So when the light tries to pass through the greenhouse gases, instead of being transparent and going right through them, it absorbs that gas and then increases its own energy. Do you guys know how to microcosm a greenhouse gas situation very, very easily that you could all do? You easily could have done it today.
No.
Park your car with the windows up.
That easy?
That's it. You park your car, windows up, leave it for 15 minutes in direct sunlight, and come back out and sit inside of it. Or if you really want to test your ability to handle it, sit inside the car with the windows closed for 15 minutes and see what happens. So I did this a number of years ago, and I put a cooking thermometer inside of it, and the temperature inside the car was 125 degrees in 10 minutes. On a day where outside temperature was 60 degrees, but the car was sitting in direct sunlight facing the sun. So think about a dog that might be trapped inside that car. I mean, you
could probably bake cookies.
You could definitely bake brownies in there if it was in there long enough. Maybe cookies. Probably cookies. I don't know. I'd be worried about the cookies because of the egg.
Oh, yeah.
Unless you had farm eggs or something like that. So what happens is the light can pass through your windshield. You know that because it's lit up in your car. And then when that light touches your seats and your dashboard and all the other things in your car absorb it, and they re-radiate that energy. And you know that because when you sit down on the seat, it's warm. So that means it's giving heat off. So you know it's not visible light because your car isn't glowing on the inside, not visibly. But if you put an infrared detector there, it would definitely be glowing. If anybody's seen like the Predator movies or any movies where they've got, or video games where they're using night vision, and they're using infrared night vision, then everything shows up, and your seats would show up if it had been sitting in that direct sunlight. And the difference is that particular radiation doesn't have the ability to get out of the window. So when it hits your windshield, instead of leaving the car, it turns and bounces back inside.
Oh.
So you end up continually putting more and more heat inside of the car, more and more energy in the car, and the car is trying to get rid of the energy, except your windows are reflecting it back inside. And that's what the Earth is doing. So you get all of this energy that comes down to the planet, and a lot of it gets reflected back off of the planet, and then the gases in the atmosphere reflected back down. So without those greenhouse gases, we would be a much, much colder planet.
Would it matter if your seats are cushioned? Would that make your car?
Nope.
No? Okay. Sometimes they say that it's supposed to heat up your car a little bit more when you have cushioned seats instead of leather seats. But
The leather seats feel hotter when you sit on them because they've got a lower specific heat than the cushion seats. We haven't talked about specific heat, but specific heat is just the ability of a substance to transfer energy. So,
Okay.
like if you take a metal spoon and you put it into soup that's boiling on the stove, your hand would eventually feel it would feel the heat really quickly, right?
Yes.
So a spoon has a really low, a metal spoon has a low specific heat, but you can sit there basically for all night and stirring it with a wooden spoon, and the wooden spoon isn't ever going to burn your hand because the wooden spoon specific heat is much, much higher than the metal specific heat. So it's just the ability for it to transfer. So when you sit down on a hot leather seat, it transfers the energy into you very fast, so it burns. And the cushion seats, they don't have that ability. So you sit on them and they're warm, but they don't burn you because they can't transfer heat in very fast. And so your body has the ability to pull that heat away before it actually starts causing problems.
Oh, okay. All right. It's because my car has black interior
Mm.
and it feels really humid inside my car compared to outside. Even if it's not super hot outside, it's like 10 times hotter inside my car.
Yeah, the black is definitely going to be absorbing all the light that comes in. So it's got to, it ends up heating the car up a lot more. Nothing gets reflected. I just noticed that people were putting questions in chat. Structural formula examples and linear. Okay. So Cami had a question about structural formulas. So let's start with a really easy one. So there's a water molecule. Does anybody know what the shape of the water molecule is?
So bent.
Bent, yeah. That's actually the technical term for it, even though that sounds stupid. Its technical term is bent. It's bent because there's an oxygen connected to two hydrogens, but the oxygen also has a lone pair of electrons here and a lone pair of electrons here. And so what's happening is there's one electron around this hydrogen and one electron around this hydrogen, and then there's these two electrons and these two electrons, and electrons have a negative charge. So anything that has the same charge opposes anything else that has the same charge. So these things that are negatively charged push each other away. So let's say that you had two, I don't know, 4-year-olds and they were fighting, and you grab them behind the neck and grab their shirts and then pick them up. Would you just pick them up in front of you? Or would you pick them up and put one on your right side and one on your left side? You'd put one on as far away from each other as possible. So that's what atoms do when they've got substances around them. So that example would be like carbon dioxide. This oxygen is actually on the left and this one's on the right, and they're as far away from each other as possible, and that means they're 180 degrees away from each other because these guys have electrons around the outside of them, and those electrons don't want to be anywhere near the electrons on the other oxygen. So they just get as far away from each other as possible. But what happens if I've got a substance like boron and it's got 3 chlorines on it? Do you think this is what the shape looks like? Are those as far away from each other as they possibly could be?
No.
What shape would make them further away?
If it was a little bit more like a triangle.
If it was exactly like a triangle, then they'd be further away, right? So now these guys are all 120 degrees away from each other, where in this example, these guys are 180, but these guys here are only 90 degrees away. And so the ones that are 90 degrees away would be pushing and pushing until they reached over and started pushing on the chlorine on the other side. So each of these bond angles here is 120 degrees because now this boron has these chlorines as far away from each other as possible. But what happens if I put a 4th thing on it? It doesn't form a square. It ends up forming something called a tetrahedral. which I am terrible drawer, so this is what you're going to get out of me. So this is a tetrahedral shape. So this is supposed to be a triangle shape on the bottom, except it's below the plane. And so that hydrogen with the dashed lines is going away from you. And this one with the triangle is coming at you. And then this one is in the plane of the board, as well as this one up top. So you're looking at a tetrahedral because they're all trying to get away from each other. And this shape here is the reason the water molecule is bent, because that oxygen has 4 things around it, and the 4 things it has around it are those and those and that and that. So this is a structural formula. Another example of a structural formula. I need to change colors here. That's a bad color. How about something like well, what would the structural formula be for 2 hydrogens connected to each other?
Straight line.
Just a straight line. They'd be as far away from each other as possible, right? And that same situation happens for oxygen, except there's a double bond between them. But what would it be for ozone? Well, you'd have to know what the ozone molecule looks like. So it's an oxygen with a lone pair of electrons on it, doubly bonded to another oxygen, and then bonded to an oxygen. So this guy here has, all right, that yellow is just terrible. This oxygen that's in the middle has one thing right there, one thing right here, and one thing right here. So what does this look like?
Triangle.
It looks like a triangle. And so the ozone molecule is actually bent because everybody's trying to get away from everybody else. So let me clear this. And I'm going to put down C2H6O2. This is the chemical formula for acetic acid. Acetic acid is what makes vinegar vinegar. It's in ketchup, it's in mustard, it's in lots of things. It's a food preservative, it's in pickles and whatnot. But I give you 2 carbons, 6 hydrogens, and 2 oxygens. Do you have any idea what the shape of that molecule looks like? It'd be like me handing you 2 black Legos and 6 red Legos and 2 blue Legos and saying, build something. Everybody's going to build something different. So the structural formula for this is actually a carbon connected to a carbon, and I got an oxygen and a hydrogen and a hydrogen, and then another hydrogen and another hydrogen and another hydrogen. And you wouldn't know that unless somebody told you. So the chemical formula isn't super useful, but the structural formula is very useful. It tells you how everything's connected up. Did that answer your question, Cami? Oh, your microphone's not working. Okay. All right, I'm going to type. Well, I guess you can hear me. Type in there the group chat and tell me if you want some more. I could give you more if you'd like. Wait, is Cami even here anymore? Oh, yes, she is. Okay. Okay, so we have another question. And the question is, can you explain fermentation from the lab I'm doing right now? So, oh, wait a second. Cami's asking, so ozone is bent, not tetrahedron. Correct. It is a bent structure and not a tetrahedral structure, for sure. It only has 3 atoms, so it couldn't be a tetrahedral. You have to have at least 5 things to be a tetrahedral, 1 in the middle and 4 around the exterior. Ronald, I'm not sure what you want me to say about the fermentation. I'll clear this out. So you need sugar, and you need something like I don't know. Well, we'll just say yeast because that's what you guys are using. And when the yeast, which is a microscopic organism, eats sugar, somebody tell me what the products are?
Carbon dioxide and something else.
Yeah, what's the something else? No, glucose is the sugar. Ethanol. So there's lots of different alcohols out there, and this is the only one you can drink that won't kill you immediately. All the rest of the alcohols will kill you like within a couple of hours. If you drank rubbing alcohol, isopropyl alcohol, you'd have 2 hours before your liver would give out and then you would just die. But not the case with ethanol, although you certainly could drink enough of it to kill you. That happened when I was in high school. Somebody at Oregon State drank a case of beer in an hour. They were dead.
What kind of beer?
I don't know. I was like 15 when I read that, so I didn't know anything about beer.
Okay.
It was probably bad beer because
Like Four Locos. Really.
Oh yeah, those are crazy.
Don't drink them.
Yeah, don't drink those.
I don't know what that is. Okay, so why do different alcoholic beverages have different concentrations of alcohol in them?
Different amounts of sugar and yeast.
It's actually not about the amounts. It's about the strain of yeast that you have. So this is going to sound gross, but technically, what is the carbon dioxide and ethanol related to the yeast?
Excrement.
All right, perfect. It's pee, right? It's them exhaling and peeing. So ethanol is what yeast, specific types of yeast, urinate out. At some point, if you were laying in a room and the room just kept filling up, say a bathtub, with your own pee and poop, what would eventually happen to you?
Die.
You would die. So that's why some alcoholic beverages have more alcohol in them than others. Sometimes the yeast can actually withstand its own ethanol, pee, longer, and then continue to eat and continue to make more until eventually it kills itself. You could also do things to stop the process, introducing oxygen into the mixture or something like that. But usually what happens is you just buy a strain of yeast that is intolerant to ethanol or one that's much more tolerant to ethanol, and then you can control the amount of alcohol in the beverage.
Is that why moonshine's so dangerous?
Well, no, moonshine is just straight up 100% ethanol. So it's dangerous because you're getting a lot of it all at the same time. And it's also dangerous because it's ridiculously flammable. Like a person standing across from you smoking a cigarette could ignite your face. Did you guys know that one of the premier yeast cellars in the entire world is in Odell?
No.
People all over the world get orders of yeast from the company Wyeast, yeast, and I mean it's a good name, right?
Yeah.
It's basically Mount Hood yeast is what we're talking about. So the yeah, if you want to make your own beer or wine or something like that, you could just go to Odell and talk to those guys, and they'll give you recommendations on what you should use.
I'm treating my dog for a yeast infection right now,
Not the
which
same
sounds really
yeast.
gross, but it's on his nails. Like I took him to the vet because he was just chewing on his feet, and like apparently you can get yeast infections in your nails, which is gross. But-
Yeah, not the same yeast. You can't use that and make alcoholic beverages.
Okay, so I can't sell Walter's toenails.
No, that's gross. Okay, can we ask a question about vibrating molecules? So the vibration of the molecules is the crux of how our planet is warm. When you measure something's temperature, I think we talked about this a couple of weeks ago, but we'll just start off by saying temperature is sort of a measure of the kinetic energy or the average kinetic energy of a substance. So what is kinetic energy? Kinetic energy's equation is 1/2 the mass times the velocity squared. So if you put a thermometer in something, you're not really measuring its mass. What you are measuring is the speed of the molecules. So I think that's easy to think about with water. So if you take a thermometer and you put it into a pot of tap water, the molecules of H2O aren't moving very fast. But then if you turn the stove on, the water molecules start absorbing that heat, and the result is they start moving faster. So that means their kinetic energy is higher, so that means their temperature is higher. So the crux of things warming up is how fast the molecules are moving, and we measure that in terms of temperature. So when somebody says this thing is this particular temperature, and then something else is colder, the warmer thing has molecules or atoms that are moving faster than the colder thing. There isn't anything else to it. If you walk outside on a cold morning, those air molecules that hit you in the face are moving slower than the ones that were inside of your house. So your body is trying to heat them up, which is why your face gets cold, because you're giving energy to these air molecules that are running into them, and they're moving slow and they're trying to speed up. So how does that work with vibration? So if I've got a carbon dioxide molecule, the interesting thing about all molecules is at no time are they ever at rest. They're always moving around, even if they're a solid. It's sort of like how you would be. You ever sat in a movie theater where the movie was like 3+ hours long, like the Lord of the Rings movies? At the end of the movie, like your butt starts to hurt, right? And your legs start to hurt and your back starts to hurt. So you find yourself moving around. So at the beginning of the movie, everybody's stationary, but then you can move around in your little space. And so you would have more kinetic energy towards the end of the movie because you're moving around. So all molecules move, and they don't just move through space, they actually move relative to each other. So this double bond right here between the carbon and the oxygen can expand out and then can contract back in. So even though they're still connected to each other, they can still go out and come back. You guys know those paddle ball things? It's got a little paddle thing on it. It's a piece of wood, and to it stapled, there's a rubber band with a ball on it.
Yep.
And you can make that thing go back and forth, back and forth, back and forth, and people who are really good at it can make it go very, very fast. That's how I want you to think about this bond between the carbon and the oxygen, that the oxygen and the carbon can be moving back and forth faster and faster and faster. And the reason this is a greenhouse gas is because this bond here, when it gets hit with infrared radiation, which is what the planet tries to shoot back out into space, it absorbs that energy and makes these things bounce faster and faster and faster. So if these are going faster and faster and faster, then the entire molecule is going faster and faster and faster, and now that thing's temperature is higher. So when I increase that thing's temperature, I've effectively increased the entire planet's temperature a little bit. But if we're talking about billions and billions and billions of these things, then the whole planet's temp goes up. So the radiation that you would expect to reflect off the planet and leave and go out to space gets trapped by that carbon dioxide molecule, and instead of making it into space, it stays on the planet, keeping the planet warm. So the carbon dioxide is really just a blanket. Does that help Cammy? She doesn't have a microphone. I think you guys can all see group chat. Somewhere on your screen, you should be able to click on something that says chat.
I can see it. I had to like exit and re-enter the program a bunch of times because Zoom stopped responding and my microphone stopped working.
Oh.
It's back now, obviously, but you know.
Was that because of the headphones?
Well, I took them off because I came to see my parents for Easter and I'm still here. So I was using that because my dad's watching some basketball. So I came back to the bedroom and I turned the headphones off. And so apparently if you turn off your whatever other device, you're like kind of doesn't fix the program and
Zoom hasn't figured that out yet. There's something wrong with their software. Like if you pulled your webcam out of the USB, it kind of freaks out and you got to start over.
I had to restart my computer after a few times.
Oh wow,
just don't do it. Just whatever you log on with, stay with it.
Usually you don't have to reboot the entire computer.
Yeah.
Okay. Anybody else? What else do we want to talk about? What basketball games are you watching?
He's watching the playoffs.
Yeah, must be.
Hey, wait, so you taught at Oregon State University. So you're a Duck? Or wait, is it the Beavers?
Beavers. Yeah, Beavers.
Oy. The Ducks had a basketball game too. They were playing Ducks, so it was weird. Oregon was playing Oregon.
That was probably the women's basketball team because the Oregon State men's basketball team is terrible. Can't infrared rays burn through? No, Cammy, infrared rays cannot burn through CO2. We're not really worried about ozone because those infrared rays, so the ozone's on the exterior of the planet, and what that does is it protects from the ultraviolet. So the ultraviolet rays actually can't really make it through the ozone layer, but all the other types of radiation can make it through the ozone layer. Let me stop sharing that, and then let's find a picture here. All right, why is that not working? All right, that's weird.
Are you trying to screen share?
No, I can't find this picture that I was sure was here, and no, it's not. So I'm gonna just Google it. Of course, just trying to sell me stuff instead of actually doing what I wanted to do. All right, so this one's fine. Open image in a new tab. We'll zoom in on that. I'm gonna go back over here, and then I'll share that picture. Okay, can we see this electromagnetic spectrum?
Yes.
Where did the chat thing go? Okay. So these radio waves and these gamma rays are at opposite ends of the spectrum. Radio waves don't have the ability to damage anything. They can travel a really long ways, and the gamma rays on Earth, gamma rays, the second they hit something, they interact with it. And these rays have a great deal of energy. So if like a nuclear bomb went off, that's how you get gamma rays. Or if you've got some kind of heavy radiation like some uranium or plutonium, gamma rays and X-rays would be coming off of that. So an interesting thing to think about is radio waves can't really interact with anything, so they travel a long distance. Gamma rays interact with the first thing that they touch, so they don't really travel a great distance because as soon as they hit something, they react. Hopefully that makes sense. So on this spectrum, the radio waves can travel the longest, and the gamma rays can travel the least distance once you get to inside of Earth. And then these other ones, it's the spectrum. So microwaves are less distance than radio waves, and infrared or less distance than microwaves. This radio wave thing can actually be cut up in many sections. I mean, it could be just radio, like AM, FM radio, but it could also be the radiation, or sorry, like a television, broadcast TV before cable came out. Walkie-talkies, cell phones are in there, and like avalanche beacons. So if you're buried under a bunch of snow and you've got this avalanche beacon and you activate it, you don't want the avalanche beacon's radio waves to be absorbed by the snow over the top of you. You want it to penetrate the snow and get out and tell somebody you're stuck underneath the snow and where you are. So that's why they would use a type of radio wave as opposed to a type of gamma ray, because gamma rays would be absorbed immediately. Why do we get mammograms to detect cancer if they are dangerous? That's a tough question. It's not the best idea. I totally agree that a person, so we didn't talk about the breakdown of this, but the breakdown is you've got radio waves and microwaves and infrared rays and visible light. And all the stuff on this side to the left of the purple color can't harm you in a way that would give you cancer. You could be hurt by a really bright light or a very, like a stovetop turned all the way up. You put your hand on the stovetop, of course it's going to hurt you, but it's not going to give you cancer. Everything to the right of purple, the UV, the X-rays, and the gamma rays, those have the ability to break a chemical bond. So when you get a mammogram and they're using X-rays on a breast, those cells can be damaged by the X-rays. But it's sort of a balancing act. Is it more important? It's not like you get X-rays and then you're definitely going to get cancer. There's a small chance of you getting cancer. So is it better to give a person a small chance of getting cancer or to find out if they've got a tumor already? And so at this point, most people are getting mammograms, so the doctors are saying it's less dangerous to get an X-ray rather than to wait and find out that you've had cancer for a few years. There should be better ways to do it, and I don't know why they're not. There probably actually are better ways to do it. But right now, people are probably making too much money doing mammograms to change that industry, which is terrible to say, but most likely the case.
It's all industries, right? I mean, a lot of them.
A lot of them.
Things change because of money, like it's just gonna.
Too many people at the top making too much money to want to make a change is really what it works out to be. There's a greed level. Like once you reach that threshold, then the person does immoral things.
Yeah.
There are lots of philosophers who didn't think that, and their writings are just plain wrong. It's been proven too many times that people go crazy once they get a certain amount of money or have access to a certain amount of money. So why people get X-rays for their mammograms? It's basically a balancing act between finding out if you have cancer or possibly giving you cancer. So yeah, it's tough.
It's kind of like chemo. Chemo hurts you and poisons your body, but it also kills cancer. So it's like you do the thing you pick one, and they still both damage you, but one saves your life.
Yeah, I'm on the fence about chemo.
Yeah.
Especially with cancers that don't deal with it well. If it's Hodgkin's, like non-Hodgkin's lymphoma, then that's one thing. If it's Hodgkin's or if it's other forms of like melanoma or breast cancer or prostate cancer, I am not sold on the chemo thing. It's, I don't know. I'd have to look at all the options before I would. Why do most people choose the chemo option though?
I don't know, with prostate cancer, I think that there's been studies that show not treating it is actually better. I mean, you're going to live longer not treating it than potentially treating it and hurting yourself more. I
don't disagree with you, Cami, that it's a last hope, but let's say that you decide I don't want to do chemo, but I want to try some kind of Eastern medicine. I'm not saying specifically acupuncture, but something in that vein. Your insurance isn't going to pay for that. And that's really a powerful reason for people to choose chemo because whatever method that they choose, their insurance company is going to pay for that. The medical field is sometimes very. There's no good reason to treat you to make you better. Nobody makes any money on healthy people. And that's kind of where Western medicine has gone, which is terrible to say, but kind of true.
It's kind of funny listening to those medication commercials on TV because it's like, this can help with this thing, but it also causes all these other things that are worse than the thing we originally had.
Right. We are literally the only country on the planet where it's legal for a drug manufacturer to directly advertise to consumers. And we shouldn't be that country.
You know, I heard something comforting though. So my fiance is a physician, and I was like, so is it true that like they get these hot reps to come in and like try to sell you guys stuff? Like, isn't that super just? And he said that that's pretty much been nixed. I mean, they can advertise. They're not going into hospitals trying to convince doctors to sell things anymore. At least
that was in 80s, 90s,
yeah,
2000s up to like 2008, 2009, somewhere in there when people started getting sued.
And I still thought it was going on until the other day when I asked about it. I was like, so it's a thing? So I don't know.
I don't know if you guys noticed or saw that there were a couple of busts in the last couple of months about fraud, Medicare fraud and opiate fraud. One doctor had prescribed so many like Oxycontins and Oxycodons to his little town that it was enough pills for every single person in the entire town to eat or take 700 Oxycontins a day for a year.
I saw that. It was like a little red building and you could even drive through.
Right, you could drive through and get your prescription for Oxycontin. It was basically just an opiate drug den. And the worst part about it is
to figure it out. Like
I don't, because we don't spend our monies in the right spot. Enforcement of or fraud is almost all fraud is caught because somebody points it out to the government. It's almost never caught because somebody in the government picks up on it just of their own accord. It's almost always a whistleblower.
But that whole opioid epidemic is like just so sad.
The company who's mostly responsible for it is actually family owned, and they're being taken to civil court. So basically what they're doing is they're trying to just take their money. So they're suing them for like $18 billion, which is more money than they're actually worth.
Do you watch John Oliver?
Yeah, he's pretty much, I would say he's tied with Colbert for me.
He's super good. But he actually was making fun of the guy that was in charge of that company, and like he actually like did reenactments of things he actually said. Like, I don't know. You should watch the episode about that.
Yeah, I watched his opioid one. I think
it was good. It was good, right? He's just like,
he's
like, yeah.
He's amazing. He just hung out with the Dalai Lama, and the Dalai Lama said that he was since China calls the Dalai Lama a demon, he transferred it to to John. So now John is a demon. He's not sure how he feels about that. Okay, let's see. I know there's a little different when human medication, but like dogs that chew flee to so Kimmy was asking about, or just stating a fact about the fact that some of the medications for dogs for fleas and ticks can cause the dogs to have seizures, and they're all those animals, including us, are going to react differently to those different medications. But the company isn't going to sell one that's going to cause seizures in most dogs, because then people aren't going to buy it anymore. So just because the medication could cause a seizure in the dog doesn't necessarily mean it's going to cause a seizure in your dog. So if you've been given that medication to your dogs and nothing's happened to them, then that's probably not a biological side effect of that medication on your dog. I'm not saying that can't happen, and I'm not saying it couldn't happen over time, but usually seizure stuff happens with medications in the first time they use it, or the first few times that they use it.
What medication was it, Cammy? I don't want to get too far off track, but
The ticks are really bad this year, and it's barely
yeah,
started.
I just got my dog on a chewable one. That's why I'm asking. Like just a few days ago, I got neck scare.
Is it monthly?
Yes. Okay.
Brave. I can't even pronounce that.
Brave.
Brave.
I think.
Oh, Bravecto. I was trying to say brave and then CTO. Bravecto. Gotcha. Not cheap.
It's interesting. I'm on my parents' bed right now, and there's this. It's a it's a medical professional sample of probiotic medical food.
Why? Is it on the
I
bed?
don't know. They'd probably be so mad. I'm like, look at this. It's 112.5 billion bacteria per capsule. It's not a mole.
It's nowhere near a mole.
We're near a mole. I want a mole of healthy bacteria per pill. I'm done. I'm sorry. You know what? Like, remember the whole me not making funny jokes thing?
So
Okay.
how many did you say it was?
112.5 billion.
That's just a second.
So 12 zeros is a billion?
You need to eat 48 trillion pills to get yourself a mole of those bacteria.
Oh my God, that's so big. No wonder
That's a lot of free samples.
48 trillion of these?
48 trillion. Yeah.
Wow.
So, I mean, that pill has, what'd you say, 12.5 billion bacteria in one pill?
112.
Sorry, 112. I might have done that wrong then. It might only be
No, it's just like,
4.8
holy
trillion.
cow. Like trillions.
Oh yeah, sorry. We need to remove 1 0. So you only have to eat 4.8 trillion of them instead of 48 trillion. All right, we're clear. Stop
I think that would probably overload your digestive system if you look at mine.
True. Oh.
The bacteria that's there right now would probably be confused. All right.
I mean, how many? No.
What else we got?
I'm gonna have more questions on Thursday once I get
Into chapter 4?
Well, I'm into it. I just haven't finished it, so I'm kind of trying. I like to read through it and then kind of go back on areas and.
Gotcha.
How do you guys turn off like the video mode? Because I can always see myself. And I don't really want to, and everybody else is like
in the
flat
bottom
screen.
in the bottom left-hand corner, because you have the application, right? You're not just running it in the browser.
Yeah.
So in the bottom left-hand corner, if you just move the mouse a little bit over the screen, you'll see something that says mute and stop video.
Okay.
If you click
So
stop video,
stop the
that's
video of
stop
myself.
the video of yourself. Yeah. Yeah. Bye.
Oh, nice.
There you go.
Okay.
Or you can just go with the video.
Oh, your audio just
No,
went away again. Ah.
That was me. I did that.
Oh. That was very convincing.
All right. Casey, any questions? Aurelia?
No, but I haven't really gotten to chapter 4 yet either, so.
Okay. Becca?
gotten through like the overview of chapter 4, like the first page, and that's about it.
Okay.
So,
Cam, are you using a laptop?
Yeah, I'm not through chapter 4 yet.
Oh. So she's using a desktop, so they usually don't have microphones and/or video feeds. The other thing is the application on the phone works great. I mean, Marilyn was just using it.
Oh, really?
Yeah, I mean,
That's
it,
good to know.
I'm on my iPad.
okay. So it does. I think that's why this piece of software, the guy who created this company came to the United States from China in a boat illegally, and now he's worth $12 billion.
Yep.
Click on that, Trump. Sorry.
Right, exactly. And he's built an application that you can, I mean, you could be on your phone, you could be on your iPad, you could be on your desktop, you could be on your laptop. We could all be talking, we could all be seeing each other. Yeah.
And then most of us turn off our videos.
Right.
I just don't like, I don't care if you guys see me. I just don't like looking at myself because then it's like, oh God. No.
Well, you
They
could
take care of me when I talk to you guys.
absolutely, Casey.
Okay, awesome. Because I'm on a lap or a desktop, but I bought like an external microphone,
Oh, cool.
and I usually just mute it because my kids are running around. They're loud. So
Okay, this is a dumb question. Is a desktop a laptop or is that just like a home computer?
home computer.
Okay. By the way, Cammie, nicely done. You doing this at work? That's multitasking 101. Good.
And you can obviously put any picture you want up of yourself.
All right, I'm gonna get a really funny one for next week.
Okay. Also, if you hover over the top of any of these people, you can mute or like not watch their video feed.
Oh.
You can rename them.
You can rename them? Oh man. There's no rename button for me. There's just chat or hide non-video participants.
Yeah, I've renamed you 4.8 billion pill girl.
Okay, that just sounds like I have a problem.
Okay, I think we've strayed a little bit. If anybody has any more questions, we can do it. Otherwise, I'll turn this off because we're at about an hour.
Cool. See you guys on Thursday.
Yep. See you Thursday.
All right, bye-bye.